Welcome to Embedded. It's just Christopher and myself this week, and may be a short one because it's summer here finally. Well, where do you want to get started?
I just feel like you're always rubbing the weather into people.
Well, it's the weather or the otters or, the dolphins. It's something.
Yeah, I think you're overselling it.
My feet are so cold right now. I can't even tell you. It may be summer out there, but in here, it's an icebox.
It is a basement.
Okay, so that was it, right?
Yeah, that was the show.
That was the show.
Have a good week, everybody. We'll be back with...
next week's guest is pretty interesting, actually. So I'm not going to drop any hints other than that. But yeah.
Do we have any contest winners to announce? That's not happening yet?
No, but thank you for reminding me about the contest. We do have the contest that Bob Apthorpe suggested. He's giving away 3 books, and you need to send me a number. And when I said unbounded, let me just say somebody has already chosen Graham's number, which is unimaginably large, I think was the definition of it.
Yes.
So
had more digits than could be fit in atoms in the universe or something like that.
So that one's taken and not a winner.
Yeah, and I feel like I should remind people that the goal of these kinds of contests is to get the number closer to the chosen numbers. So unless one of us had chosen Graham's number, it feels like that's the I don't want to win position.
Even if I had chosen, what is it, a Google?
Yes.
That's still, if somebody else had chosen 0, Graham's number would not win because it's, on the other hand, I am learning about all sorts of interesting numbers. So, either way is fine with me.
I'll give a hint. The one I chose is a perfect number.
Is it? It would be nice if I remembered which one you chose, but happily I wrote it down.
I don't remember what I chose either, but I do remember it was a perfect number.
Okay. So there are 3 numbers in play, and we need them by October 1st. You people have complained that the contests don't run for long enough and you're behind on your podcast listening. So this is a long one.
Well, it's been summer. People aren't obliged to listen to every podcast the instant it comes out.
No, they're absolutely not.
I mean, we don't like them as much if they don't, but, it's no requirement.
I don't really grade my friends on whether or not they listen to the podcast and at what, how quickly they are up to date on my current content.
Seems like a good criterion as any.
As any, no.
What's on the docket?
Well, speaking of current content production, I do want to say that Andre's new series about the STM32F4 Discovery Board is starting out and going along. It's going to be pretty cool. Where Svek takes a very microcontroller and let's look at this from the assembly perspective. Looks like Andre is going to start more on a data sheet. A data sheet has a lot of information, can be kind of confusing. So let's talk about what's the useful parts. And he's going to talk more about the Cube MX and all of the things surrounding ST and their environment so that you can just get started. Of course, it's never quite just get started.
Especially since didn't they rev the board after he wrote the first entry?
They did rev the board. That was his first entry is, well, crap, this isn't an entry.
Thus invalidating all the prep he'd done.
Yes.
Yeah.
And I am working on a 2 or 3 part series in which I try to explain Bayes' rule, which is the same as Bayes' theorem, which is pretty much the same as Bayesian inference. And I try to explain it in terms a narwhal would understand. And if you don't know what a narwhal is, it's the unicorn of the whale world. It's awesome. And they're real.
There's no proof of that.
There's actually a lot of proof of that.
So would you like to briefly explain Bayes' rule without the aid of visual narwhals?
Whiteboard? That makes it a little harder. Well, in my posts, I've been doing it in sort of a comic book style. And one of the things that has really been useful for me going through it is the idea that it isn't just one thing. It's how you update your current predictions based on what's in the world. And so that has machine learning aspects to it, of course, because your robot needs to update its understanding of the world every millisecond, every minute, whatever time scale your robot's working at. But it's also used in forecasting and predictions, like people like Nate Silver who do the political predictions, or even I've heard it's used a little bit in weather, although that one doesn't make so much sense to me. But it's a way of taking what you know and what's likely and what's unlikely and putting it all together in a way that allows you to make sensible choices. And there's been some small, tiny group that says you should apply this to your life all the time. I don't know that I believe to that, but it's kind of neat. And it's one of those terms that people run into, and then you see it explained in a statistics book, and then you run away from it every other time that you've ever seen it. So I'm hoping to make it friendly.
So that was all very general. Bayes' rule in particular is about how to compute conditional probability.
Oh, yes.
Right? So you have two events, and they might be independent, but they probably aren't. And you know something about the probability of one event, and you might know something about the probability of the other event.
Yes.
And you might know something about the combined probability.
But
Bayes' rule says,
yeah,
given I know this, what's the probability of this other thing? Is that right?
Sort of.
Okay. Correct me.
So let's take the idea of you see a light in the sky and it's weird. So weird light in the sky. What is the probability that that is a UFO?
100%.
Given that you have seen a weird light in the sky. And I'm using this example because somebody tweeted at me.
It is unidentified, therefore it is a UFO every single time.
All right. Aliens. Let's go with, what is the probability it is aliens?
92%.
That it is a light in the sky.
All right.
So now, if you look at it just without any useful forward thinking, it's the probability of both of those things. It's the probability of seeing a light in the sky, which you don't always, every time you look up, you do not always see an unidentified light in the sky.
Okay.
And the probability of it being aliens.
Okay.
So you have to think about it as both of those things are happening. A lot of people are like, well, what's the probability of aliens?
What's the top level question, though? Are there aliens in the sky right now?
The top level question is, given I have seen an interesting light object, are there aliens in the sky? What is the probability of there being aliens?
All right. It seems weird to me that you take into account the probability of there being a light in the sky.
Well, you do have to, because it acts sort of as a normalization problem.
I see.
Because, right now there's one giant light in the sky because it's daytime.
Probably definitely aliens there.
And it's not unidentified. So, there's some...
Okay.
And that goes back to you need A and B to be true.
Got it.
You need both conditions, both the light in the sky and the aliens. And so that whole, is it aliens given I've seen light in the sky, is equal to this first part that's sort of the likelihood. And that's the weird one that people look at it and it's like, that's just the opposite of what you said before.
So
that's the one
first part is, given that there are aliens in the sky, is there a light?
What's the probability I'm going to see a strange light? Okay. And that's the funny one. I mean, given there are aliens, no matter what the probability of aliens is, but right now we have aliens, what is the probability there's a light in the sky? Because you know what? Aliens should be cloaked. I mean, really, shouldn't they be? Why do you expect a light in the sky just because they're aliens?
So that's zero already, so you're done.
Well, maybe there are 1% friendly aliens who come.
Maybe it's the Close Encounters aliens who have the Christmas tree lights all over their ship.
They did have lights. So you do have to know that probability. You can't really go on unless you can make an estimate of that.
Okay.
And then that's the likelihood of, when people talk about likelihood, that's sort of what they're talking about, is that you had A given B, and now your likelihood is B given A, and you're like, That makes more sense when you talk about what's the probability of getting a positive test given that I have a disease, or given that I don't have a disease. What is the false positive rate?
Sure.
And then you're looking at the other side when you're looking at, do I have a disease given that I've gotten a false positive? It starts to make more sense with statistics.
Okay.
Aliens less so. Okay, so now you have the likelihood, given that aliens are here.
So let's just ballpark this example for fun.
Okay.
So let's say aliens have to have lights on their ship. No cloaking devices.
Okay.
So if there are aliens in the sky, then there's definitely then there's lights.
Then there are lights. So that's a
very
definite
high probability. So let's call that 90%.
Okay. So all their aliens are shiny.
Yeah.
Okay.
All aliens are shiny.
We're making so many good show titles right now. So the next term is the probability of aliens.
And that's probably, let's specify that a little closer. Oh, you're going to look it up.
No, I'm not looking.
You're going to look up the aliens? No, are you looking at Bayes' rule?
I'm not looking at Bayes' rule. I'm just making sure that I got this right. Yes, it is the probability of aliens is the next term.
Probability of aliens in general in the universe?
Probability, I mean, it depends on where you want to set that. If you want to start with the probability of aliens visiting Earth.
Okay, so that, let's say, is very, very low.
Okay, so now you have something that's almost true with something that's very low.
Yeah, so 0.0001.
And now you're going to divide both of those terms, which you've multiplied, by the probability of there being lights in the sky.
Which is high. Depending where you live, it's pretty high. So you've got a small number.
Not 100%, but you probably see strange lights maybe once a year.
So the way we've built this, we've got a number close to 1 times a very, very, very small number. So we get another very, very small number divided by a large number. Mm-hmm. So the probability of it being aliens when you see lights in the sky is low.
Right.
Based on our completely bogus ballparking.
Well, that was one of the things I wanted to do with my drawing was to do that ballparking. Don't worry about, what is the exact probability. But there's highs and there's lows. And if you have a high times a low, all right, that's usually a low. And if you divide that by a high or you divide that by a low, it changes it. Mm-hmm. It was kind of fun in the comic. I managed to prove is definitely under air quotes, that unicorns are more likely than mermaids because there are fewer land-based animals with single horns than there are marine-based mammals who sing. I know it sounds tortured, but I've been having a good time doing it, and so that's been my project for the blog. So,
where would you use this as a software developer and embed it? Does it come along with things like Kalman filters?
No, the chances are you won't use it as an embedded software developer. You'll just hear about it, and then you'll be in a meeting, and it'll be, I'm not even going to ask you a question because the last time I saw that, it was so intimidating. But it does revolve around machine learning and how they come up with algorithms.
Okay.
When we talk about the aliens given the lights in the sky is a feature. And then you're trying to figure out the probability of some event given a feature. But when you talk about gunshot location systems, you have features of how loud is it, how far is it high frequency or low frequency, and you start adding these probabilities all up, and you can get a good sense of, is this a gunshot or is this a basketball bouncing, even though initially they're both just impulsive things.
Can you think of simple examples for robotics and stuff where it might be navigation or trying to pick out some object in the visual field?
Are you reading ahead on my notes?
No, I'm generally curious how you could use this because, so I did all this in college and forgotten it all, but, now I'm thinking about it and going, you could have a little tiny, you could build the equation for a certain conditional probability you're interested in for a kind of motion or action you want a robot. Robot? Did I just say robot?
Ribbit.
a robot to take.
Well, in what I worked on today actually was the page where I have a treasure that my sailor has found. He's the Narwhal's friend. Boy, this really just gets weird. I have a treasure, undersea treasure, and it's cursed. And you can only take one and you have to close your eyes. And there are round pearls and there are coins that are gold and coins that are iron. Now,
And the coins feel the same.
the coins feel the same. Now, given that, you want to take spherical things because those are more valuable. But then I dump some marbles in and I add coin pearls, so now everything's kind of weird. And so at each stage, do you want to take spherical or do you want to take coin? And that's going to be dependent on what's already been taken out of the system. And that was where I ended up building a robot, mentally. Drawing, graphically, not really.
Conceiving of a robot.
And so the robot chooses based on what's left. And that's a simple, it's a while loop. While the robot is not evil, if the probability of spherical having good stuff, wait a minute, if the probability of good stuff given a spherical object is greater than the probability of good stuff given a coin-shaped object,
Sure.
then take a spherical, otherwise take coin-shaped, and then repeat. Update all your probabilities and go on.
But you need to keep track of your probabilities as you go along.
You do. And the way that I set up the problem, unfortunately, Bayes' rule isn't that important. I mean, it's a reasonable example because you're using the equation and getting accustomed to it. But it goes back to, at some level, we're talking about the A and B being true. I mean, A given B, sure, that's Bayes' rule. But in the end, if all you really need is a static solution to a static system, it's A and B. And probabilities are easier to calculate than the Bayesian probabilities.
So,
if you have all the other information.
Yeah. Okay, so that's cool. You mentioned people saying you should apply this to your day-to-day life. And I was thinking about that, and I think, well, humans are bad at probability, number one.
We're really bad at probability.
But we're really, really bad at conditional probability.
Yes. Unless you think about
intuitively.
Yes.
And so this, I mean, it's kind of fun to go through little mental exercises about maybe things that bother you, like, say, flying on a plane.
It's actually one of the, that's like 2 pages from today.
I'm sorry, I'm writing your thing. But yeah, but you can go through and say, well, flying on a plane, let's make it an example with worse, probably more realistic consequences, like flying on a tiny plane or something like that, or a hang glider, something that's a little bit dangerous. You can look at that and say, well, how likely is it given that for me to crash on a hang glider?
Right. What is the probability of crashing given that I am on a hang glider?
Right. And Bayes' rule teases out that little piece that would say, how often am I on a hang glider?
Yes. That's the divided piece.
Yeah, and that's the important part, because if that number is very, very small, your likelihood is...
Well, there's also the probability of crashing.
Right.
I mean, that is, what is the probability of crashing given I'm on a hang glider? The probability of crashing overall, given all of the other sorts of ways you can, motorcycles and cars and helicopters and all these other things.
Oh, the probability of crashing in anything?
Well, it depends on where, you can take, that's how you end up with things like you're twice as likely to be in a wreck if you're in a car, because you're twice as likely to be in a car.
Right.
Or 1 million times more likely to be in a car.
Yeah, and that's the piece that
these
people...
things out.
But that's the piece that's interesting, because you don't think about that intuitively. You only see the top level probability of some event happening from some aggregated statistics over the entire population. You don't have a chance to say, yes, but how often am I doing that thing? Or, yes, but here's another piece of information that changes that's specific to my circumstance. And this rule allows you to incorporate that information, which, you might be able to do a back of the envelope calculation and say, oh, well, that thing I was worried about, yes, this statistic says it's reasonably likely, but given this aspect of my life, it's less likely. That's all.
Yes, and it lets you look at statistics that you might not otherwise consider. Like, I plan on doing the whole crashing with airplanes problem, given all kinds of crashes. Well, if you start to think about that, and you start to think about all the other ways you could achieve this event, given all of the other features, all of the other vehicles, all of the other, bicycles.
You should encase yourself in concrete.
Well, either you come up with that, or you come up with, well, hang gliding isn't that dangerous.
See, I don't think that's the conclusion you want to draw. Or that thing we saw this weekend, which was
kite surfing,
hang gliding from a surfboard.
It was,
or something.
It looked like fun. It looked like a great way to break all of the bones in your body.
Yeah, maybe that's a good dismal probability example. Given that there are 40 kite surfers in a quarter-mile long length of beach, what is the likelihood that they're going to crash into each other?
You kept waiting for them to tangle their kites, but I think they were further apart than they looked.
Well, we'll put a picture up. Okay, well, that's enough on that. Thank you for indulging my interest.
People out there are like, you can't do this without a whiteboard, because I feel like you can't do this without a whiteboard. But
you can do anything without a whiteboard. It's just whether you can do it well.
Yeah, and this sadly was lacking in narwhals. Okay, let's see. Steve, quite a while ago, emailed us and said he wanted to give us a show idea. And Steve, I have to admit, I like your show idea very, very much. He was listening to NPR, and they had a story about reintroducing endangered toads.
Was that this NPR, computer NPR, or regular NPR?
Regular NPR. And the interesting part was that every toad had a tracker attached. And Steve wanted me to talk to the person who built the tracker. And I seriously looked, because I thought that would be awesome. I could not find the person. I could not find the company. I couldn't find anything useful to get me to that person.
So that's the end of that story?
I'm sorry. Actually, it was more of a call for help. If anybody out there knows how to track toads, we would like to hear from you.
All right.
Let's see. So Daniel says it would be awesome if we could produce a show that gets into some of the challenges and details about what it would potentially take to move an electronics project from maker to consumer level. He's been working on a handheld device for a while and feels he's about to hit a wall of ignorance in his effort to get to market.
Yeah, that's a big one. We've touched on this before when talking about our...
Lately, it's
well,
been...
even when we've only touched on it.
Yeah.
But we've talked about Arduino. And I'm not saying that's what's happening there, but yeah, there is a big gap between prototype and production. And I don't know. I mean, we could talk a long time.
It's a steep gap.
It's a steep gap. Well, it depends on volumes.
Yeah, if you're making consumer products or medical products, it's so much more work than you can imagine.
Hundreds of thousands to millions. Medical products, maybe not, but still.
But that has its own separate
hopefully
issues with FDA or certification problems.
Yeah, I don't think we want to do that today, but we should certainly find somebody who would be good to discuss that with.
I was thinking about talking to one of the hardware accelerators and trying to get somebody from there.
And that's, I think, what you really need if you're going to... I don't think I would recommend anybody try to do that on their own, especially if they don't have the experience.
Yeah, that can be an expensive and scary proposition because they do want quite a lot of your business. But having it fail because you can't
do it at all,
fulfill your orders, is pretty heartbreaking too.
It's funny because we've gotten to this weird position where you can build pretty sophisticated stuff with modules and without, a lot of hands-on electronics. Basic understanding of electronics is all that's necessary. When in the distant past, say the 80s or the 90s, you had to build your own board, and you're probably out there, pouring etchant on stuff and making PCBs yourself if you wanted. Maybe you did it on a breadboard, but you're still wiring things up. So it was a lot closer to... Where am I trying to go with this? It seemed like it was a lot closer to, I understand what's needed to produce this thing. than
And now you can buy it
buying a
off the shelf.
microcontroller with a board, which some other companies already spent, a year, 2 years developing and putting through mass production. So you're leveraging somebody else's mass production to make your prototype, but that doesn't help you get from prototype to your own mass production.
Well, and selling things is remarkably difficult.
Well, I don't even know how to comment on that.
It's just, we're engineers and we're like, if I build this, that they will come.
No.
And if only, but there's so many other things, and the noise to get past everybody else's small widget is very difficult.
And I would remind engineers, we're pretty stupid about marketing a lot of times. I mean, just speaking for myself, there's a lot of products out there that I've been involved with that I've thought, this is going nowhere. Who's going to want this? And then it sells like gangbusters. So I don't understand what makes a good product. I really don't understand what makes a good product, or a product that's going to catch on in the market. And vice versa. I mean, there were companies I worked at where I was sure, this is going to be a hit. This is the greatest thing ever. Look at this advanced technology we've put together. We built the space shuttle 6 times over. Everybody's going to love this. We're going to make millions. And so, don't be too sure of your market prowess.
On the other hand, Kickstarter and even Etsy with their tiny electronics, their custom bespoke electronics.
Wow, please don't make that a thing.
Please don't make that a thing. No. Might be cool.
Artisanal bespoke electronics.
Well, I think it's more for things that are built into art.
Yeah, sure.
But that's a way to dip your toes in. But even that's a pretty big...
It's a way to gauge if you have a market, but it's also a way to get in deep trouble.
It really is.
So
okay, moving along.
Good show idea. We'll work on that.
Carmen Parisi from the Engineering Commons show asked over Twitter if he wanted to bit bang a bus that's close to SPI, how would he go about getting started? He's doubly not a software person, so we definitely have to take that into account. So have we defined bit banging before?
I don't think so.
Okay.
If we have, it was just a throwaway comment.
So sometimes you end up with a processor or even a peripheral, but mostly it's a processor doesn't have the peripheral communication method you need. It doesn't have SPI, or it doesn't have I2C.
Or one wire.
Or there's some wackadoodle peripheral communication that the peripheral needs, like one wire, or my rolled up version of one wire because I had to do it different because I don't like standards. Somebody out there is doing their own thing.
Right. And
sometimes you have processors that can support these in, you kind of shove NeoPixels or the WS2812 LEDs. You can shove those into SPI if you work at it.
Okay.
The timings work out, and you just
That's
have
fine.
to. It's not normal SPI, but it's close enough.
But the basic idea is you've got dedicated hardware on the processor that handles these buses, and if you're lucky, you say write to SPI with this address, and it just does it. And it wiggles all the signals in the right order and does it at the right timing, and you don't have to worry about any of that. And it'll do DMA for you. And now you're saying...
That's really nice. That's very cushy, the DMA. Okay.
Now you're saying, I've got a processor, but maybe all I've got are GPIOs.
Right. And so bit banging is using the GPIOs to replicate a bus communication. And so if I wanted to do Morse code as a bus communication, this isn't, the best example, but hey, I'm just talking here.
No, I'm going to take this and do it now. Morse bus.
So let's say I have an accelerometer that speaks Morse code, and it's got one line that we both share. And so I have to say, when the line is down very short, that's going to be a dit, and if it's down longer, it's a dash, and we're going to communicate back and forth, and I have to have like over or something, some way to say it's your turn. Well, you can kind of imagine that spelling out the dits and the dashes with a timer. You can say a dit has to be 50 microseconds, but no more than 100 microseconds. It has to have some timing. And a dash has to be, I don't know, say a millisecond, something horrifically long. And it too can only have a little bit of slop. It can always have some slop, but it has to have a little bit. Well, now you can do this with a GPIO. You can sort of picture how to do this because you're toggling it up and down. Your processor isn't doing much else because it has to keep on top of these things.
Yeah, the timing has to be, depending on the bus you're using, the timing might be very strict. And so you can't go away while it's doing something.
You might be able to put it in a timer interrupt.
Right.
And then every time you do the interrupt, you do whatever state machine you have to do to get to the next step. So maybe if I'm doing SOS, I do a dit and a dit and a dit and a dash and a dash and a dash.
Right.
And then that lets me sort of organize, queue the information that's coming through. But I'm still just, GPIO up, GPIO down, GPIO up, GPIO down. Depends on the timing, but that is the only thing I get to change. Now, if you're doing SPI normally has the clock line, which is clock. And that's going to be pretty easy because you are going to put that one on a timer. And then you have the...
maybe.
Okay, well, we won't put it on a timer.
Because you want it to be synchronized with your data bits. So
you have data bits in and data bits out. And let's just work on the data bits out because that's pretty easy. It's sort of like the Morse code. You have a clock, so you wait for some period of time to make the clock happy. You put your clock up. Now you wait for half of a clock period, and you put your data into whatever state it needs to be. And then you put your clock down, and the other person samples on the down of the clock. Now, whether or not you are sampling on the up or the down depends on your SPI mode, and there's a Wikipedia article about SPI, and that's the only way I remember whether you're sampling on up or down. And
see, for something as complex as SPI, you kind of want a state machine, probably.
I think so. I think you would want a state machine.
But for something as simple as one wire, you probably can get away without that because all you're doing is one wire only has signal. The clock is embedded in the data, so you can you have writes and you have reads, and you just need to get the timing right and wiggle the signal line.
On the other hand, if you are doing bit banging on a UART, like a serial, you have to have very precise timing because you don't have a clock to go along with this. You have to be 9600 baud, plus or minus 10%, or the other person won't understand you.
So I would say, as advice, I would read the data sheet, or not the data sheet, read the protocol specification for your particular thing. Probably the
peripheral will have detailed specification.
Very closely. And this might be one reason you're doing it, because sometimes the peripherals are a little weird. And maybe, I don't know, in the past I've encountered peripherals that don't work well with a particular SPI with a...
SPI and
I'm overusing the word peripheral. A device, like an accelerometer or something, doesn't really work with your SPI master peripheral for some reason. And so you fall back to, okay, I've got to do all the timing myself. That's kind of a place you don't want to be in, but I can see that happening.
Because it is a huge suck on your processor. It just it's not good. I did come across a tutorial about Arduino control of the WS2812 LEDs. And they talk about bit banging it. And what I liked about this particular example was that they did it in assembly so that you would really understand that the timing of this is critical.
Yeah.
But on the other hand, you should read your data sheet and make sure the timing, if it's critical, this may not be the processor you want to use.
Yeah, you should ask yourself why you're in this position to start with. But if you do have to do it, then you build it from the data sheet, and I would build from kind of the bottom up. Okay, here's a write function, here's a read function, depending on the protocol, and then build on top of that.
But you're almost certainly doing a state machine because you need to do something at each clock tick.
And I would advise people to write it in such a way that they can rip out the layer that does the bit banging
when they get a real processor.
When they get a real peripheral, so they don't have to rewrite a bunch of stuff that's all spaghetti code and intertwined. But yeah, God, the example I remember most was I came into this place that had already picked a bunch of hardware very strangely. It was a PC single board computer, so x86, and I guess it was running VxWorks. Yeah, VxWorks. And then they had National Instruments PCI boards for digital output, and that needed to talk to one wire. So it was VxWorks, doing bit banging over an NI digital out board, digital in and out, doing one wire. And that worked mostly kind of.
And that isn't an example of the processor being deficient. It's just you had a layer that didn't work together.
It was deficient because it was, it was basically a general purpose computer architecture, which doesn't have SPI or I2C or one wire. And back then, I don't think there were one wire masters on anything, so it didn't really matter.
I mentioned in SPI whether or not you sample on the rising edge or falling edge depends on parameters. Those didn't used to be parameters. Those used to be you had to get the right one, and one vendor had this kind, another vendor had that kind, and your peripheral had to work with the vendor.
That's what I'm remembering.
And it was awful. Yeah. And that is where bit banging really, it's why we all know about it. But now even I2C seems to be a lot easier to put in and a lot easier to manage. There's fewer derivatives, fewer wackadoodle separate things. Okay. So hopefully we've answered him. And I will post the bit banging.
I don't know if this is called bit banging, but there's lots of projects now where people make things wiggle in a processor to generate RF. Did you see the code that runs on any USB stick, and it does accesses to the USB stick so that it will transmit radio waves to a receiver? So somebody can put code on a USB stick and plug it into the computer, and they can steal stuff.
That would be very slow.
Because it's a radio transmitter. It was quite slow, but it worked, which was sort of terrifying.
It is also sort of terrifying.
Yeah. Yeah, you can I've seen projects where people make radio transmitters by just hanging an antenna off a GPIO and going to town with the thing. I'm not sure that's bit banging because it eventually becomes analog, so maybe it's just bit wiggling.
I guess we should have asked Carmen to ask his question, and then we could have asked this question back to him. Would have been fair. Okay, next question from Ben. You convinced me unit testing is good. Now, how do I get started? Ben is
That's not my job.
Self-taught software engineer, and he's having trouble getting started in unit testing with embedded C++. He tends to work with Mbed or Arduino boards, but does that even matter? Mm-hmm. How does he set up a unit test? What tools should he use? Should he use hardware emulators or mocks or how do you actually do unit testing?
Well, there's this podcast, and it's called embedded.fm, and
we don't unit test the podcast. I don't know where you're going with this.
We've had a couple of episodes, is what I'm saying, where we've talked to experts on this very topic.
James Grenning has been on the show a couple of times, and he has a book, Test-Driven Development in Embedded C. I think it's Embedded C. And he has all of the answers to your questions. It's setting up the environment. It's separating whether you want to use mocks.
And what the mock is what?
A mock is a lower level that
fakes out
your hardware.
Yeah, okay.
And he sets it up so that it all runs on your PC. And it's in C++, which is slightly odd, but it works. And we also...
The framework is in C++. Your code doesn't have to be.
No. And it's pretty nice. I've used his framework at a couple places, and it's a pretty easy framework. And the fact that there's a book that tells you how to do it really helps.
Which one is that? Which framework?
CPPU test.
Okay, that's the one. Yeah. Yeah, I've used that too.
And then we had another guest. I want to say Vandervoord.
Come on, you're expecting me to remember? I think that's right.
Tentacles of the Kraken, Mark Vandervoord.
Yes.
And he has throwtheswitch.org, which is a good place to get started for test-driven development. He has a couple of courses on how to do it and where he really walks you through videos. I seem to think James might be starting that as well. He has some online courses.
Yeah, I know he does training, so...
So either one of those, whichever one of those sounds best to you, is a good place to start. And
I would definitely just start with James's book and then branch out from there, because it's easy to...
Well, we're both book people. I'm starting to really understand that there are people who are video people. And I'm not really one of them.
People killed the book star?
I see. Maybe. Yeah. And then as for how do I use it, sometimes I use these frameworks. Sometimes I am in a client who really doesn't like those for one reason or another. Usually it's something about having been burned in the past about offline testing and online testing being different. And so with those clients, I usually do on-chip unit testing in a separate project where I'll test each module and have them build and compile and load separately. So it's an extra step. It doesn't happen on every compile, and they get broken when other people change your interfaces. So it's not as good. It's better if your team can really do it together.
It depends on your project too, because maybe you can run all your unit tests off device, which is really nice because then you can do it nightly, automated fashion, and you get a report back. Or anytime somebody commits something, that's a great one because you immediately get feedback that this is broken. This thing that you didn't think you were changing. And I would say the thing that I think stops most people from doing unit testing is a completionist attitude. Like, I got to unit test this whole thing.
Oh, no.
I think pick the most important parts of your product, the most important pieces of code, maybe the core algorithm, maybe the thing that is doing most of the thinking, and start there.
Yeah, pick the mathy piece. Pick the piece that you've gotten confused on twice now.
Yeah, or pieces that are likely to get some change pretty often.
Yeah.
Because I see a lot of things where people will write a unit test for a module, like a device driver or something. And that device driver gets solidified really quickly, and then it never changes. And so the effort to do a bunch of unit tests for it, it's questionable whether that's better than just having it locked down through the normal course of testing in the first few weeks of use. I don't know. I'm still kind of towing this in my mind. But
there are times that unit tests overlap with manufacturing tests for me.
Well, that's important, yeah.
And so those driver level things,
I'm not saying
I like to put them in unit tests because I like to write the tests early and get them over to manufacturing.
I'm not saying don't do it, but be judicious about what you unit test.
You don't have to do everything.
Burn yourself out on it. Yeah. That's what I'm worried about.
And I think James said that, you do one improvement a day is sufficient. You just have to keep doing that.
I don't know how you're going to unit test your one-wire bitbang driver. One thing we didn't talk about, that derailing this and going back for a second, is the receive side. If you have to bit receive, that can be a challenge too, because...
But then you have a clock and you sample on every clock or whenever you need to sample.
But you may need to time things.
Because if you are receiving SPI and you are updating not on clock edges, then you have to go halfway between what your clock is. It does get confusing, but it's about sampling at the right time and making sure you keep doing it.
Yeah, don't do that.
Yeah. But going back to this, Ben asks about Mbed or Arduino, which made it a little harder to answer because Mbed has their code online.
Yeah.
And then you have this step where you have to go online to offline.
Did they have any framework as part of the...
They didn't last time I checked. Arduino's a little easier. You can fake out setup and loop by just making a C file that calls setup and calls loop at the right times. And you don't need all of the other Arduino stuff happening. But Mbed, I don't think they have a testing facility. If I ever manage to get one of the Mbed folks on, we'll grill them about that. Yeah,
that seems like a potential area for trouble. Although, I mean, you can export the code and use CPPU test, right? It just is a little painful.
It's another step.
Yeah.
And I think Mbed now has reasonable version control. So,
do you think people are using Mbed for products? Like using the IDE and things?
I think they are. There's a lot of stuff there. But as far as I can tell, everything's public.
Because I would expect people to grow up out of that, much like they grow up out of Arduino and then move to a standard tool set where all of this is possible.
I don't know. I've never used it for product. I've only used it for hobby.
Yeah. I would certainly hesitate using anything like that for a product.
But then you look at the price of IAR and a debugger and you're like, well, I don't have that much money to drop right now, and this is free.
Well, then why are you making a product?
Well, there's that. And it's not free because it's on every board. I'm
definitely not saying go out and buy IAR if you're making a product or no, that everyone should have the quantity of money. No. I don't want that to be a barrier. But there's certainly embedded alternatives to IAR that are not costly. The entire GNU tool set, for example. Yeah, rolling your eyes. Oh, no.
No, I want to like GNU, but OpenOCD is
OpenOCD.
If you name something OCD, I should have known I'd have to follow every step each time perfectly. Nahum from Ethiopia. This was sort of interesting. In my country, it is not easy to source materials for projects, and I've always wondered what would be the cheapest way to use a normal LCD computer monitor. Those are readily available for about $50 US, and Nahum wants to use it as a display for electronics projects.
Oh boy.
Please exclude Raspberry Pi as that is not available.
Oh boy.
Ideally, if there exists a board one could make with some microcontroller, then that would be ideal.
So here's what I would suggest.
I think BeagleBoard has to be excluded as well.
That wasn't what I was going to suggest.
Okay, go ahead.
First, I have to assume that the computer monitor has VGA input. If it does not have VGA input, then this all gets a lot harder.
Right. So there's VGA is one standard for driving LCDs, and HDMI is another.
Yeah, and VGA is analog.
And VGA you can do with a microprocessor.
You can do
HDMI. You really have to have an HDMI
so you can
driver.
Basically, and going back to the first part of the show, you can basically bit bang VGA with a powerful enough microcontroller. And I think people have done it with Arduino. You'll have to look it up, but it doesn't take much, although it takes a lot of your CPU power. So as you said, if you have two of them, one can be doing display and one can be feeding it. So VGA is what I would look at. There's many projects on Hackaday that I've seen that have done this. It can, of course, be done with an FPGA, but that's if you don't have Raspberry Pi, then you definitely don't have access to FPGAs. That would be the only route I could think of beyond getting some small chips that drive like TV signal, composite output TV signal, like they do for some of the heads-up displays that overlay on first-person view for radio-controlled planes and things over the camera. Those are available, and they can do some basic line drawing and text, and those are individual ICs. But I would explore the VGA route if your displays do. If it's HDMI or DisplayPort or something is all you have access to, or DVI, I don't know how easy those are to drive. Well, I know HDMI is extremely hard to drive because you need the encryption stuff. Don't know if DVI is easy to drive. So yeah, VGA.
VGA is the way to go. And VGA is also the way to go because it has a higher voltage range.
Oh, okay. Very friendly.
And so it is friendlier to the Arduino style processors. Stay off the processors that are 3.3 volts because those are likely to cause trouble.
Okay.
Let's see what else. I said this was going to be short, but we aren't cooking through this as fast as I expected.
No, that's because I made you explain aliens.
Frank says he has not heard the first 70-ish episodes, but would like to.
Yes. Yes.
So
we have this plan.
Squarespace holds 100.
And iTunes holds 100.
iTunes holds 100. And I have to say, I never imagined we would have too many.
Yes.
But Libsyn, who hosts the actual file that holds the audio, there's no limit there. So there's an alternative link that you can use, although I don't know how to put it into iTunes or anything.
It's an RSS feed.
It's an RSS
So
feed?
it's an alternative RSS feed from the Squarespace one. It has all the episodes. The problem is we hadn't been keeping that up to date, so there were no show notes. So we've been slowly going through and copying the show notes over.
Well, I did it in a couple of bursts, and
yeah.
then I kind of, at around 70, I started working on Narwhals.
And then we had a major distraction, and we didn't finish. So we have taken this
on the list.
Taken this as a prompt to finish that up. We will put the alternative link in the show notes. It goes all the way back to episode 1. I will add it to Squarespace once we have copied over the show notes, and people should be good to go if they want to do that.
Yes, so you can listen to the early ones. And there were some really good early ones.
And if you want to complain to Apple and Squarespace,
that would be okay with us too.
Yeah.
You know, 5 stars. I just wish I could listen to all of them.
It's not my fault.
Spencer Owen noted that Chris was talking about building his own 6502 computer from scratch. Spencer did a similar thing a few years ago, but based around the Z80. He says it was a fantastic learning experience. Gets down to the nitty-gritty of what a computer really is. And then he has this as a kit, a minimal computer kit. It's available on Tindy, and I will have it in the show notes so you can look for that.
This was quite cool.
Yeah, it was.
Yeah, and the Z80 was a really cool processor. We talked about that a little bit a couple episodes ago, but that was another one of those interesting little late 70s, mid 70s processors. You could learn in an afternoon. Okay, not really, but you could imagine learning it in an afternoon compared to what we have to learn now.
The processor I'm working on, the user manual, 1,400 pages.
Is that all?
Well, it doesn't include like USB stack or anything. That's just the processor. And it doesn't include the fact that it's a Cortex. So there's a whole nother manual out there. Yeah. And I feel like I'm cheating because I'm just reading the sections I want. I'm not even skimming the others.
It's gotten to the point where it's like the laws. Like if you want to you can't understand every law because they're all thousands of pages long. Yeah. So no, you're not expected to.
I expect me to.
Well, if you want to learn the whole processor, go learn one of these.
Yeah, I think the Z80 would be a lot more satisfying for that. Jim GF also had a comment about a previous show, the one where we talked about quadcopters with fly bricks, Rob Walters. And then before that, we had talked about the dodecahedracopter. And apparently there's a TED Talk with an actual professor showing off an 8-prop helicopter, 8-prop quadcopter.
It would be an octocopter.
Octocopter. I can't say that.
Octocopter.
Every time I point at you, you have to say it. Okay?
Octocopter.
Anyway, Jim sent us a link for that, so I will include it. It was a pretty cool little talk.
Well, I'm sad that somebody's almost done what I suggested, but heartened.
They're 12 short.
Heartened that there are 4 props short. 12 short.
I thought it was 20.
You're going to make me look bad.
One of us is going to look bad.
It's funny when I type in dodecahedra, the first thing comes up is dodecahedracopter. .com. Dodecahedron. 12.
12. All right. They're only 4 short.
Whew. That was close. That was close to exposing my lack of... There's no 20.
That's sad.
Maybe.
How can we make
what's
D&D dice without knowing this?
Oh, you're right. No, what's it called? Special cases of the pyritohedron. The tetragonal, pentagonal dodecahedron. Well, that's ugly.
I'm sure people tune in just to listen to us say these things that sound implausible.
It's fine. They like us. They have to listen now. It's in their podcast downloader.
Yeah, they can't stop the car and switch.
It's too much work to delete a podcast you subscribe to.
We did get an email about the ACM having a code of ethics, which was pretty cool. ACM is the Association for Computing Machinery, Why I joined IEEE instead of ACM, I don't know, but yeah. So maybe I need to go look at that some more. And if you know about it or you were part of making it, email, and maybe we will talk some more.
What? We'll have a whole ethics episode?
Nah.
Is that ethical?
Who knows? Okay, let's see. I will be looking for a new gig soon. Not right away, but soon. I haven't quite finished the old one. So if you have something interesting, I would like to remind you that we put on a podcast and that we write interesting things on the on the blog, and that I do a little bit of management of my co-contributors on the blog. And this is all the stuff I do for free. Imagine what I do if you pay me. Was that a good ad?
I'm not sure. I'm still thinking about it.
Okay. So anyway, I will be looking for a new position soon, and possibly I will be speaking at the Silicon Valley IEEE Computer Society in early October. I probably shouldn't have just slagged IEEE. Oh. And for those of you who purchased my book because we told you that I have a book, thank you very much. I do appreciate it, and I hope you like the book. And if you don't, please give it to someone you don't like.
You going to do a second edition soon?
The whole toy book, which is sort of on the shelf right now, metaphorically on the shelf right now, stopped that. But second edition is sort of in the works. I don't think we're going to change a lot. I think I'm going to redo the math chapter, and I'm going to add a little bit about manufacturing process.
Well, and you're going to talk about BLE. You're going to have a big fat chapter explaining
BLE.
BLE, right?
I'll be updating some of the communication protocols, but I don't want to write a book about BLE. I want it to be general.
You want to have written a book about BLE?
No, I want it to be here's how you design things, here's how you build things, and here's how you go out and look at other people telling you how to do protocols. And then the big change for the second edition will be, I'm hoping to redo all of the images to also have words behind them for people who can't see. But also in case we actually do an audio version.
Audio version of a technical book? That doesn't make sense.
There have been a couple, and I find it very amusing.
Are you going to get to read it? Oh, you want to do it? That's fine. That makes sense. I was just thinking amusingly, have Will Wheaton do it or something. It wasn't meant to be a slag. It was what random person can we get?
And with that, Christopher, do you have anything else?
I don't think so, but I can come up with something. Oh, now. No, I don't think I can come up with something right now.
All right. Well, then I'm going to close the show now.
You're going to close the show?
Well, not.
We're turning the sign around. Yeah. No longer says, welcome, come in.
Thank you, sort of, to Christopher.
You're taking that artificially more negatively than you need to.
Yeah. Maybe Bobcat Goldthwait will read it.
Oh, that would be great. See? I can't do a Bobcat impression, or I would right now.
Anyway, thank you to Christopher for producing and co-hosting. And of course, thank you for listening. If you do have guest suggestions, I'm not running short, but I always like to hear them. So go ahead, send me your guest suggestions. And if you know them, if you have their email, it is so much easier because then I'll send you a little introduction and you can forward it along and it will all just smoothly happen. You can also email them and say, you should be on this show. And if they email me, anyway, guests. And we have a blog. We talked about that. We have a YouTube channel.
Subscribe, people.
Subscribe.
Y'all asked for it. Actually, you didn't, but
I think like 3 people asked for it, and they did subscribe. So I think we're
they're obliged to get their friends to subscribe.
There's a contact link on Embedded FM that will direct you to the YouTube channel. It will also direct you to sending
subscribe.
us. Oh, I see. Well, Yeah, okay. And it will let you email us. It'll let you sign up for the newsletter, which is still working. Yay. So it does lots of things. Go to the website, check out the show notes. There's going to be a lot of links in the show notes.
Yeah.
So now, Winnie the Pooh. Let us continue with Winnie the Pooh from last time.
This is going to take a really long time.
It really is. So when we last left Winnie the Pooh, he was nearly at the top of the tree to get the honey, and he had stood on a branch and crack! "Oh, help," said Pooh as he dropped 10 feet on the branch below him. "If only I hadn't," he said as he bounced 20 feet onto the next branch. "You see what I meant to do," he explained as he had turned head over heels and crashed on another branch 30 feet below. "What I meant to do? Of course, it was rather," he admitted as he slithered very quickly through the next 6 branches. "It all comes, I suppose," he decided as he said goodbye to the last branch, spun around 3 times and flew gracefully into the gorse bush. "It all comes of liking honey so much. Oh, help." Embedded FM is an independently produced radio show that focuses on the many aspects of engineering. It is a production of Logical Elegance, an embedded software consulting company in California. If there are advertisements in the show, we did not put them there and do not receive any revenue from them. At this time, our sole sponsor remains Logical Elegance.